All right, here we are going to explore net and sine area. You already know that the definite integral will give the area under the curve. So here, let R be the region bounded by the continuous function y equal to f of x and the x-axis between x equal to a and x equal to b. I'm going to represent this one graphically over here. You can also add that to your note catcher. Say, for example, this is my vertical axis or y-axis. This is my horizontal axis or x-axis. So that's my x-axis. That is my y-axis. And assume that there is a function y equal to f of x. So I'm going to draw a random function over here. Say, for example, the function is like that. So this one in blue is the graph of the function y equal to f of x. And R be the region bounded by the continuous function y equal to f of x, and the x-axis between x equal to a and x equal to b. Suppose this point on the left is x equal to a, and that point over there is x equal to b. And the area bounded by that function and x-axis between x equal to a and x equal to b is denoted by r, and it is this area here. You can see there is area, certain part of the area above the x-axis, and also there is certain portion of the area below the x-axis, like that. And if I want to find the total area, this total area is considered as R. So suppose I'm labeling that area as R. So if I add all these area, that is equal to R. So R be the region bounded by the continuous function y equal to f of x, and the x-axis between x equal to a and x equal to b. Now there are two things that you need to know here. The first one is called the net area. First thing is net area. Let me write that here. Net area. It is the sum of the areas of the parts of R above the x-axis minus the sum of the areas below the x-axis. That means if the area above the x-axis, if you add all the area above the x-axis, if it is R1 and all the area below the x-axis is R2, then the net area is all the area above the x-axis minus all the area below the x-axis. So that's how you can find the net area. Net area is R1 minus R2. Similarly, the net area is also the value of the definite integral from a through b of the function. That means if I want to integrate this function from x equal to a to x equal to b, I can also write that over here, integration from a through b of the function with respect to x. The value of that definite integral from x equal to a to x equal to b is also equal to that net area. That will be equal to R1 minus R2, area above the x-axis minus area below the x-axis. So if we use that concept and we try to evaluate the net area over here in this graph, let's see what we get. So for this graph given here, the net area, if I want to find the net area, that will be equal to area above the x-axis is 2, area below the x-axis is also 2. So that will be 2 minus 2 or 0. And also that 0 is the value of the definite integral from 0 up to 2 pi of this function. So if I integrate from 0 up to 2 pi, if I integrate from 0 up to 2 pi, this function sine x with respect to x, that is also equal to 0. Example, find the value of definite integral using the graph given here. So here is the graph of the function. It is said that the function is f of x, and we have the areas given here. Area above the x-axis from a through b is 12. From B through C, the area is below the x-axis, that is 10. And from C through D, the area is above the x-axis, and it is 8. First, we have to find the integration from B through D of the function. So B through D, you can look at the graph and indicate that part, B through D. So that is the reason from B up to D. And you can see that for this reason, you have 10 below the x-axis and 8 above the x-axis. That means the value of the definite integral from B through D will be 8 minus 10, because area above the x-axis minus the area below the x-axis. That's how we can find that value. So it is equal to 8 minus 10. So let's write that down. That is equal to 8 minus 10, or negative 2. Similarly, in part B, we have to find the area or the value of the definite integral from A through D. From A through D, that is everything. We are looking at the entire graph from A up to D. So if we look at the entire graph from A through D, you can see that 12 plus 8, that is 20, is the total area above the x-axis, and 10 is the total area below the x-axis. So it will be 12 plus 8 minus 10. That will be the value of that definite integral. So that is equal to 12 plus 8 minus 10. 12 plus 8 is 20. 20 minus 10 is 10. Now in part C, we have to find the definite integral from A through C of that function. A through C, if you want to highlight that and check it, it's from A through C. So let me show that over here. From A through C is this one, from A up to C. You can clearly see the area above the x-axis is 12, area below the x-axis is 10. So value of this definite integral will be 12 minus 10. So that is equal to 12 minus 10, or positive 2. So this is how we can use the concept of net area to evaluate the definite integral when the graph of the function is given.